So I'll go on to think about Spearman rank correlation coefficients. So if we recall, they were based on the ranks of the data, and in fact all that happens in regression is the regression analysis is fitted to the ranks of the data rather than the exact values. And this allows us to get p-values to test whether our Spearman rank correlation coefficient was significant, just as the ordinary correlation coefficient. So whether or not we're basing it on ranks for non-parametric data or the actual data themselves for normally distributed data, we can still get out a p-value to test whether there's a significant correlation between two measurements. So this is just a couple more examples showing both the ordinary correlation and the Spearman rank correlation with the p-value from a regression attached to them. And you'll see that they're quite different. For this red blood cell count, the correlation with platelets is quite different depending on whether you use the conventional correlation coefficient and assume the data are normally distributed, or work with the ranks. So that's an indication that you should probably use the rank. The rank correlation coefficient is more appropriate. These plots, if you did a histogram, you would see it more clearly, but you can see it's not really a very kind of symmetrical distribution. There's quite a few odd, low outlying values for the one on the bottom, which is red blood cell count. And the same thing happens when red blood cell count is correlated with band neutrophils. The correlation coefficients are quite different, and in fact the Spearman one is almost significantly positive, and it's difficult to tell that from here, but when you work with the ranks rather than the exact values, that's what it's telling you is happening, and you can see that these data are very sort of asymmetrical, not very normally distributed as well. Always bear in mind there's a Spearman rank correlation coefficient, and it might be more appropriate sometimes. ANOVA and other parametric tests, then we do make assumptions when we're doing regression. Unless you're basing it on the ranks, you're assuming that the residuals are normally distributed, and the residuals are the differences from the individual points to the fitted line. And you can assess the residuals by doing a histogram maybe, or I've got a residual plot which is plotting the residuals on the y-axis against their predicted values. This doesn't look too bad, but there's one nasty outlying observation over here that you would want to investigate, because that's really going to skew your regression and your correlation unless you use the ranked data. So if you could get rid of that, if there was a reason that this was wrongly recorded, you would want to take that out of the data set. If there wasn't, you would have to keep it in, and then you'd be better working with the ranks, the rank correlation coefficient.